Hi, and welcome to this brief video on the new features for Virtual Data Warehouse version 1.6.2. This new release is almost done. It's in its final stage of being tested. And before I release it to the releases section in GitHub, I thought it would be interesting to go through the functionality that's already available, but that we're rebuilding into templates so we can leverage the pattern engine and the generic schema for data warehouse automation. This is specifically about creating complex structures such as point-in-time tables, dimensions, but also creating table structures like DDL, data definition language statements, or referential integrity checks, creating test data, things like that. So the powerful thing about this is that I hope this shows that even these complex or arguably different ways of generating code are also supported by the schema definition and the templating engine. And it didn't really take that much time to rebuild it. Before I remove all the menus from the application, I thought it would be interesting to show what the difference is. So for example, here we have the menu option generate test data. That has been there for a long time, and it comes with a specific screen that you can define what kind of output you're looking for. Things like adding a truncate statement or how to treat hash outputs. Do you want it in a binary hash or character hash? These are things that are effectively coded into the application. So they're meant to work in a certain way. Using a templating engine makes this a lot more flexible, and that's what I wanted to show. So if we use the function as already available, what is basically happening in the background is that there's a couple of calls to the database to say, hey, what kind of tables are we working with, and then using the catalog or the data dictionary information to create insert statements with scrambled data or generated data, random data, based on the data types of the information we already have. So how to do this in a pattern engine? What I've done, and taking this as an example, I created in the staging area patterns a pattern called generate test data. Generate test data is pretty easy, and what it does, it will loop through the list of mappings in a specific file, so reusing the existing metadata files, and then for every mapping, perform a function a number of times. And this is where things get interesting, because how do we do that? How do we run things multiple times? And this is where we go into a function called replicate. We can see that we have a replicate statement here, and we're basically saying replicate something 2 times. And let's make it 10. And I can then just let me select one. I can then see that whatever I'm putting in that block will be done X amount of time. That's easy enough. This replicate function is not part of standard handlebars or standard templating engines. So this is a function that I've added specifically for the purpose of making things work or keeping the existing functionality in this virtual data warehouse pattern engine. But there's more to that, because we not only had, and I'm going back to the original template, we also have the use case of generating randomized data corresponding to the data type of the attributes we are processing. And this is what we're going to see here, because basically what we need to do is to evaluate what kind of data type we're looking for, and then based on the output of that, do something specific. There's a couple of functions that are also added for this. One is called random number, and we also have a random date, and last but not least, we've got random string as well. And random string and random date, they sort of behave how you would expect. So let's just take all of this out, and we're just going to say random string. This will generate a random string. And there we go, and we can run this many times, and we get random strings. We can of course combine this with the replicate function to do something many times. So if I want to replicate this 100 times, so it doesn't replicate the same string 100 times. It executes whatever is done in this block 100 times. So you would get 100 different random strings if everything works as expected, such as this. And then we get 100 different strings. This random string function also comes with the option to define what kind of length we want to have. So if I want a string for 25 positions, we would then get bigger strings. So these are things that have been added to support the case of, or the functionality of creating the test cases. So now if we look at the template itself, what we'll see is that we, in this case, only provide 2 cases for each table. And then we just do a string compare to say, hey, what kind of data type are we looking for? And based on that, execute that specific random function. And this is what we're going to do with the string compare function. Now, the string compare function is also another addition to the engine. So if we use this keyword string compare, we can say that a string is evaluated against something else. So in this case, a equals b. And then we can say if it's the same, say something. So in this case, it's the same. Else, it is not the same. And then we close off this function like so. So this does an evaluation, and in this case, string A and B, well, they're not the same. If I want to change this to A and A, then it's the same. Going back to the pattern, this is done in a number of times. So where is this data type coming from? We're looking at the data types of the data items that are coming through the JSON file and using that value for this evaluation. I'm going to run this now. And then we can see that because we have a replication factor, if you like, of 2, we only get 2 test cases. And this is how the functionality to generate test data with the replication here and generate the database and truncate, how this has been rebuilt in the new version of Virtual Data Warehouse. Another example is the generation of referential integrity. Again, this looks a bit similar. We have a new form coming up or new screen coming up, and then we have a couple of options, like do we want to generate code that checks all the data in the solution, or do we want to check only the most recently processed data against the solution? So these are essentially 2 templates, and we may want to tweak them in different ways. To show how this works, it generates code. This is again built into the application. If we want to build this into a pattern, I've done that for the context, the satellite type entities. I'll just select one. And there's a template built in, or has been added. And again, this adding templates is something anybody can do themselves. It's not built into the application, it's just a configuration. So I've added a new template to the solution and then said, okay, for every element in this list, go and build this statement. And this is where it gets interesting, because we're basically looking into doing a count star from the virtual context table, the virtual satellite, and seeing if there is an entry for this in the hub that should belong to it. How do we know that? So how do we know that this satellite belongs to this hub? And this is where we go into the schema definition again, the underlying structure of the metadata following the generic schema for data warehouse automation. And I can sneak peek into what that metadata is from here. So if I generate the same statements again, it shows you all the metadata that we get for this particular mapping. So there's a lot of standard stuff that comes from configuration. And then we have the name of the mapping. That's fine. We have the source. That's fine. The target. But here we have a list or an array that tells me which of the metadata elements are related to the object in question. In this case, we have a hub and a satellite. So another way of looking at this is that you've got 3 components building a subject area. And we can say, look, the first one of this list is our hub. These are conventions. And this is a way you can use the schema to generate the output you're looking for. And that's what happens here. So the related data objects, we're getting the name of the first one. And by convention, that's our hub. And this is how we can run our checks even against the database directly for all of them. And now everything will be generated, everything will be checked. Generating against the database is also changed in this version because we don't want to store connection information necessarily, especially in the metadata. And a lot of information is already managed in Team or any other application you use to work against these metadata files. And again, Virtual Data Warehouse only consumes these metadata files and doesn't create them. But we can say what kind of connection, in this case, the connection key, it's a pointer to a connection string effectively. Do we want to apply the output of this pattern against once we select this generating database checkbox? So if this is enabled, then whatever is mentioned here is where this information will be run against. The last example I wanted to show is about point in time. There has been a function to generate point in time tables or dimensions or facts or things like that. And this is one of the initial patterns that explain the concepts in play here. There are some really extensive and really well documented design patterns on the weblog. So they're in the publication section and I can recommend having a look. And they are building on concepts that are explained here. And this is an interesting screen because there's a lot of things in here that are geared towards generating the output. And what is needed is that some of the components that look into the application of the metadata, so the generation of the patterns, that's something that can be done in VDW. But some of the definition of what kind of elements we want to select and what kind of tables we want to join and sort of the navigation of the query by combining certain objects in the data model, that's something we need to define in the metadata management tool in this ecosystem. That's the team application. So I need to split this screen out. I'm going to move this to the team application and leave the code generation component here. Well, how this works currently is that we can select a couple of elements from the available data, and then we generate a point in time table from here. This has always been, for demonstration purposes, it's correct, but it's also very simple to look at dimensions this way. But the basic date math and the complexity and the condensing, they can be discussed and used as a starting point from here. So what I want is that this output can be generated using the metadata schema as we are generating everything else with. I've created a new file, the point in time dimension, and I'll just show what happens here because this is the metadata that's being selected. And again, we have a source and we have another source and we have another source. This is one of the examples of adapting to the latest version of the schema for data warehouse automation, because the definition is that you have one or more sources mapping to a target. That's one of the more fundamental principles, and that's what we can see here, because we have three tables of which we select a couple of elements, a couple of attributes, and we map it to a target dimension. We don't really need more than that. We just need to know which tables map to this target and what are the attributes we want. If we have that metadata, then we can generate the point in time dimension at that level of detail. And any other application of condensing or different timelines or all of that, that's a pattern definition, so that we can add more patterns to create the use cases as you would be able to use in the current form or the current screen. But the generation of this structure is something that is done in team. So I'm taking the output of the team file and then applying that to the pattern. I'm going to disable this. Let's generate in the database straight away. And we can see here, and you have to take my word for it, that this is the same output and it works the same way to give us a point in time table exactly as we would have for the information that we've been selecting here and generating it from here. The difference is that this is coded. This is generated by database calls and checks and code in the application. So it's not very configurable unless you go into the code. This is super configurable because anything you want to do here can be applied to the pattern straight away. I hope this was an interesting overview of the latest thinking and changes that are coming your way for the virtual data warehouse. I think it's a really powerful example of the flexibility of these kinds of templating engines. I will put this all in the release section in the next few days, hopefully. And then we have a new working version, which is a lot simpler. You only have a couple of tab pages. It all depends on the metadata files. So that application-wise, it becomes simpler and simpler, which I think is a credit to the power and flexibility of the underlying metadata schema. So again, looking for feedback, and thanks for listening.